Behold. All right, Baz, here we go. Um, I stitched it together a little bit. There's like gaps right there. It's like off right here. Yeah. I get it. I'm not a perfectionist, but I'm sure this probably really bothers you. Anyways, let's get started off. Iron core formation cutoff point. Let's see. Iron core formation. All right, so right here, I have star has collected most of its iron here. Majority of iron is in core there. Okay, so let's separate that too. Star has collected most of its iron here. By the time it's in a Neptune stage, because that's about the smallest it can be to collect as much iron it's gonna have to make the core out of. That's about this versus like something that can collect iron this size or this size or this size. Yeah, this is about where it's gonna collect the most iron it's ever gonna have they can build the core with. So all the iron's there by this stage. Majority of iron is in core here. This is when the iron has already got to the core, and this is where the core is still very compressed, very hot. It's still what geologists call liquid, even though it's super compressed and it behaves like a solid. And then about here, this is the terminal phase curve. Terminal phase curve is where the star dies. Iron core is nearly solidified. It means once that core solidifies, the magnetic field goes with it. And when you take away the magnetic field, it's bad juju. The star dies. This is the stellar death phase curve, terminal phase curve right here. Now I can go a little bit earlier, a little bit later, but for the most part, it happens around this general area. And when the Earth moves into this stage, we better have found a new home because this place is going to be completely uninhabitable. It's going to be like Venus. Luckily, we have a lot of time. This little gap right here is a couple billion years, but let's not discuss that anymore. Titan sits about right here. Titan transformation curve. See how it comes up right here? It just rode right below the Taylor threshold. Couldn't really make any life, even though it has large hydrocarbon lakes. It was evolved enough to form large hydrocarbon lakes and complex molecules, but none of it just came alive, so to speak. If it had more mass when it was evolving earlier during its life, it probably could have made some life happen. Io sits around here or right here. I'm not too sure. I have to really consider where Io sits, and its transformation curve is right up here. So it just blasted down here or blasted down here. I'm not too sure where it fits. If you're cool with it, I want to call this curve right here a Bolt transformation curve after Usain Bolt, because this would be really fast as well. This can possibly change. Of course, all of this can change, but this is just to get some things down. As well, look at Io here. See Io. Now, it says ocean worlds. Clearly, Io does not have oceans. But what this means is that Io, if it had enough mass when it was going down here, if it had made enough mass, it would have been an ocean world. We're looking at what it could have been. Coulda, woulda, shoulda. I could have been a big time astronomer making, $400,000 a year and whatever, getting a bunch of awards and prizes, but I turned out to be like down here where Io is. And all the big name astronomers and big pundits getting all the prizes and stuff, they're up here. It's sad, but whatever. Just kidding. Yeah, the Taylor threshold stops here. No chance for life. Now, this little red area, you can get rid of that, because the Taylor threshold is basically the life transformation curve. This is where life can form. As long as the object is up here and it has a lot of material to work with, it will be able to make life. And that being said, I would look at it like, okay, here's a kind of silly analogy. Say, as a blue giant, everybody starts out with a big factory full of equipment and ingredients to bake a single cake. okay? And look at the cake as being life. Over time, the components start breaking, the factory disintegrates, the workers, they quit, the ingredients get stolen or go bad, and eventually it reaches a point to where you have a set amount of ingredients, a set size of the factory, a set amount of equipment to work with, and then you can start making a cake. And it takes a long time to do this. Now, if you had a factory where your equipment started breaking too fast and the factory, there's a leak in the roof and it damaged a lot of equipment, it would go down here and you wouldn't be able to bake a cake because you have less ingredients to work with. You have less material to make the cakes. You have, just nothing is there. So look at this as being the ingredients for life. I think that's the best way to look at it. And the more ingredients you have, the better off you are. And when you move up this direction with mass, as the star evolves, as the star has a lot of mass, lots of ingredients, lots of tools to work with, it's going to bake a cake. It's going to be like Earth. It's going to have life on it. And here's where a super Earth would be, right up there, for those who are interested. Anyways, as well, you can also look at Mars. I think Mars would probably sit about right here, and its transformation curve goes right up there. And this means it had life on it, but Mars is already really dead. There's no reason to visit it. No magnetic field. The atmosphere is almost completely become a vacuum. We shouldn't be sending astronauts over here. Look how far dead it is. It's way deader than Venus. We should send astronauts in the future to objects that are at least above the terminal phase curve, where the object can host life and is habitable. As well, being that Mars is on this transformation curve, that tells us one thing. Boom. It had oceans. And here's something also interesting I want to share with you guys. Mars is on this transformation curve right there. Now, let's see. Mass. Okay, what was I going to say? Oh, yeah. There it is. Mars sat right below where Earth was in its transformation curve. So that means when Mars, with its gravitosities, when Mars had the same mass as Earth, remember mass goes up in this direction. When Mars had the same mass as Earth, it was an ocean world. It was covered in thick oceans, which is really, really cool. So it was a small ocean world, but Mars's ocean world was the same mass as Earth. And when the ocean started evaporating and it was Earth stage, obviously it evolved faster because, remember, this is time. It reached Earth stage earlier than Earth by, what would that be? Probably about 1 billion years. This isn't coming out right. But, yeah, there's that. Terminal phase curve, got that. Taylor threshold, this is out because Taylor threshold is life-centered. It's a life transformation curve. And basically, if you come down here, I guess you can keep it going, but that is more or less a disintegration area. Yeah, so gosh, there's so much more to talk about here. But I guess I can make another video. This one's already like almost 10 minutes long. Let's see, what else can I... Oh yeah, I mean, the bolt curve, it can come inwards probably, more than likely, or go outwards. I'm not too sure. But as well, the reason why I like the thickness of this right here is just to show people like how many objects are out there. There's so many objects out there. As well, given I believe the universe to be infinite in age, this thing goes all the way down here, man. And that means there should be meteoroids and small asteroids by the hundreds and hundreds of trillions and trillions and trillions of them. But those are all broken up bits and pieces of these objects up here and of these objects. After, of course, these objects have, solidified. But yeah, okay. I think that's long enough. I guess I can write more on this. I made it bigger so I can write more stuff down. All right, later.